So in this video, what I'm going to do is go over what I call part 4 of the forces and charge worksheet, putting it all together. So this is to do some extra practice problems and kind of get it at a different place. So what is the relationship between charge 1, charge 2, and force if both the charges quadruple? So realize that if I'm multiplying charge 4 by 4 and by charge 2 also by 4, it's going to go up by a factor of 16. So 4 times 4 is 16, so the force would go up by a factor of 16. What happens between distance and force if the distance quadruples? So again, quadruples is meaning it's going up by a factor of 4. It would go down by a factor of 4 squared, which is going to be, again, a factor of 16. So you're going to divide it by 16 or multiply by 1 over 16. So again, if I change the distance, I increase the distance, the force is going to go down by that factor squared. So what is the bigger effect, distance or charge? So distance, because it's an inverse squared relationship, is always going to have a much bigger effect than a direct relationship between the charges. So if I am changing the distance, that's going to be far more substantial in terms of changing the force than it is the charge. This is what we call Coulomb's law. We talk about it in chemistry. It's also talked about a lot in physics. So that's why we're using kind of physics examples here for the newtons and what we're discussing. But it is called Coulomb's law. So in your Go formative, you should have the answer 30N for that one. This is 2.5N. Letter C. Force between two charges is 10N. If the two charges is doubled and one of the charges is doubled, what is the new force between the two charges? So again, the distance is doubled, so we'll do that second. So I always suggest you do charges first. So if it starts at 10, I double it, it goes to 20. And then the distance is doubling, so that means I'm going to multiply it by 1 over 2 squared. So essentially I'm taking 20 and dividing it by 4, so that's how I got 5 newtons. So that is the explanation for where that number comes from. And finally, letter D is 10 newtons. So on the back page, number 17 and 18. So this is essentially the derivation of Coulomb's law. So you always are taking the multiplication of the two charges. So what is happening to the charges over the distance squared is equal to the force. So this is pretty close to Coulomb's law. So if you look up Coulomb's law, you'll see something very similar to this, depending upon if it's more of a physics-based or a chemistry-based Coulomb's law. So again, this is really what we were trying to get you to see through the data in terms of the newtons. So finally, we have charge and force is what we call a direct relationship. So anytime you have a direct relationship, the graphs are going to be a linear straight up, because as you increase charge, you're going to see an increase in force. The one that is the most interesting is the inverse relationship. So it's more of a curve, and there is a way to make this more of a straight line if you take the log of it. But distance, as you increase distance, you're going to see the force is going to go down. So if you have a closer distance, the force is going to be much bigger. So this should be a much smoother curve, but it is an inverse relationship.